on transformations. We're going to graph functions that have, say, a minus sign in front. Graph f of x is equal to, say, negative x squared. Well, we know how to graph x squared. If you have a minus in front, you just draw it upside down. That is, it reflects across the x-axis. Since x squared goes like this, negative x squared is just upside down. Problem is done. Next one. Putting a minus sign in front just is a command to draw it upside down. Somebody asks you to graph f of x is equal to not x cubed, but negative x cubed. This is the same as x cubed with a minus sign in front of it. Okay, well, remember, x cubed, you go like this, and you go like that. But since we want negative x cubed, I probably should have dashed this, because it's not really the graph we wanted. And then all I do is I draw it upside down, across the x-axis. I do the mirror image across this line. I draw the mirror image. Instead of going up that amount, I go down that amount. Instead of going up that amount, I go down that amount. It's the mirror image across the x-axis. Some graphs don't matter. For example, if I ask you to graph negative, well, let's think. I guess that's not true. So now, if I ask you to graph not the square root of x, but negative the square root of x, well, square root of x goes that way. Just draw it across the x-axis. Goes like that. But it doesn't level off like I drew. It goes down and to the right forever. Just like it goes up and to the right forever. Okay, so now, naturally, let's do some more complicated graphs that have minuses. For example, if I ask you to graph g of x is equal to negative x minus 3 squared plus 4. Okay, this here is a negative x squared graph. So I'm just going to draw it upside down. I go to the vertex, which is what makes this 0, and what that says. That is, I go to 3, 4. I go right here. And I make believe that that is, let me just label my axes. I make believe 3, 4 is that real axis. That is, that's the new origin. I don't tell anyone I'm thinking that, but that's just what I think. Okay, and then I draw my U shape, but like always. Now, when I draw my U shape, I think it's clear that I'm not going to hit the x-axis, but I'm going to hit the y-axis. So to find the y-intercept, we let x be 0. So y is equal to negative 0 minus 3 squared plus 4, which is negative 3 squared plus 4, which is negative 3 squared is 9. So it's negative 9 plus 4, which is negative 5. And of course, I did make one mistake, a major mistake. Since it's a negative x squared, I need to draw it downward. And yes, it's going to cross the x-axis. And how I caught my mistake is, how can I be crossing the y-axis at -5 if I was going up? Okay, so we know we're going down. We cross the y-axis at -5. Let her see where we cross their x-axis. The x-intercept, that's where y is 0. So 0 is negative x minus 3 squared plus 4. I'll bring this to the left side. It'll become positive x minus 3 squared plus 4. Well, what do you square to get 4? We're squaring this and we're getting 4. That must be 2 or -2. X minus 3 is 2, or x minus 3 is -2. Well, we all know that 5 minus 3 is 2, and we should know that 1 minus 3 is -2. So it crosses the x-axis at 5 and 1. And here is your graph. It's a narrow one. Well, 5 should be here, excuse me. There is your graph. The hardest part is finding the x and the y-intercepts. But you find a new vertex, a new origin, and then you draw a negative x squared graph. Okay. Suppose you were asked to graph the following. You're asked to graph f of x is equal to negative 1 over x minus 3 squared minus 1. So if you ignore the horizontal shift and you ignore the vertical shift, you get a negative 1 over x squared. Now remember, 1 over x squared goes this way, so negative 1 over x squared is just going to go that way. So that's the graph I'm going to draw, the one that I dashed. Let's find the vertex. What makes this 0 is 3. What this says is negative 1. So I go to that vertex. I go to 3, negative 1. And since it's all below the x-axis, let me draw it a little bit higher. 1, 2, 3. Call that negative 1. So it's as if the new origin is right here. Now, when I draw, when I draw this type of graph, I'm only hitting the y-axis. Okay. So let's find the y-intercept. The y-intercept, that means x is 0. Y is equal to negative 1 over 0 minus 3 squared minus 1, which is negative 1. 0 minus 3 is minus 3. Square it, get positive 9, minus 1. This is negative 1 and a 9th. So if negative 1 is right here and negative 2 is right there, it's like right here. Negative 1 and a 9th. Like right here. Alright. Well, so there it is. There it is. Okay, it's just a negative, it's the 1 over x graph upside down. the negative in front just says, draw it upside down. Now you could use symmetry in these graphs. The fact that if they're odd or even. I'm not big on that, but in the last video I did mention it. Suppose I tell you h of x is not the square root of x plus 2 plus 3, but rather negative the square root of x plus 2 plus 3. Well, what's the vertex? What makes this 0 is negative 2. What that says is 3. So that's my new origin. And I'm going to go there, and I'm going to draw a negative square root of x graph. I go to negative 2, 3. Go right here. And I think of this as my origin. My y-axis, my x-axis. I think of negative 2, 3 as the origin. And then, normally, square root of x graph goes that way. In fact, it always does. But a negative one just goes upside down. Well, I hope it's clear that when I go upside down, I'm going to pass both the x and the y-axis. Let's figure out where. Okay, so what I just drew, bye-bye, because it's most probably wrong. Okay, X-Intercept, the harder one. That's when y is 0. 0 is equal to negative this square root stuff plus 3. I bring this to the left side and it becomes positive. The square root of something is 3. The square root of something is 3. Square root of 9 is 3. This must be 9. X plus 2 must be 9. 7 plus 2 is 9. So x is 7. That is, okay, that is, I'm going to cross the x-axis at 7. Now we go for the y-intercept. That's when x is 0. Y is negative 0 plus 2 and then adds 3. 0 plus 2 is 2. So it's negative square root of 2 plus 3, or it's 3 minus the square root of 2. Now, the square root of 2 is in between 1 and 2. Negative the square root of 2 is in between negative 2 and negative 1. You reverse the order of everything when you multiply by negative anything. In this case, negative 1. Now, I add 3. I add 3 to all sides. So I get that the square root of 3 minus, 3 minus the square root of 2. 3 minus the square root of 2 is less than 2. That is, all I know is it's in between 1 and 2. Okay, it's in between 1 and 2. It's right there. And I draw an upside down square root sign, square root graph. And I made a mistake. 7 is right there. Okay, there is your graph. Now what we're going to do is we're going to replace x with negative x. Now that's a reflection across the y-axis, or the new y-axis. That is, if I give you y is equal to the square root of negative x, instead of going this way, we go that way. If I give you y equals not x cubed, but negative x cubed, Well, that's an interesting one, because instead of going this way, I'm going to go that way, and instead of going that way, I go this way. But you know what? This is negative x cubed. That is, it's x cubed with some minus sign in front, which says draw it across the x-axis. Instead of going like this, go like that. Instead of going like that, go like this. Either way, I'm getting the same answer. That is, it's this here, it's the bolder one. That's negative x cubed. If you're asked to graph y equals, now instead of x squared, if you have negative x squared, well, that's not going to matter, because x squared looks like this, and the mirror image of the right part across the y-axis goes like this, and the mirror image of what was over here becomes this. That is, you just get back x squared. That is, many of these functions you don't have to worry about whether it says x or negative x. But for square root graph, you do. What about negative? Or what about 1 over negative x? I don't like that one either. When you plug a minus sign in, when you replace x with a negative x, it's the mirror image across the new y-axis. That is, if you were asked to graph y is equal to negative x plus 2 minus 4, which is also known as 2 minus x square root minus 4. Well, what makes this 0, or what makes this 0? 2. X is 2. And that does say negative 4. Okay, so just where I go. I go to 2, negative 4. Right here. And instead of going this way, I'm going to go that way. And I'm going to hit the x-axis and the y-axis. Which means I have to find the x-intercept. The x-intercept. That means y is 0. 0. Oh, okay. Is equal to this square root stuff minus 4. I bring the minus 4 to the other side, and I get this square root. The square root of negative x plus 2 is 4. The square root of 16 is 4. The square root of 16 is 4. That means this must be 16. Negative x plus 2 must be 16. Take away 2. Negative x must be 14. If I change the sign of that number, I have to change the sign of that number. X is negative 14. It crosses, it's insane, but it crosses way to the right. That's the y-x-intercept. The y-intercept is when x is 0. So y is equal to the square root of negative 0 plus 2 plus 4. Negative 0 plus 2 is 2 plus 4. And remember, the square root of 2 is in between 1 and 2. Add 4 to all sides, and you get that the square root of 2 plus 4 is in between 5 and 6. But now that completely makes no sense. The vertex is correct. Okay. When x is 0. Oh, it clearly says minus 4. I don't know why I wrote plus 4. Right here it says minus 4, but I've been writing plus 4. Sorry. Okay, good. So it's minus 4, minus 4. So now I take away 4, and I get a completely different answer, which hopefully will be better. The square root of 2 minus 4 is in between negative 3 and negative 2. Negative 3, negative 2, right here. So the graph looks like that. It's a negative square root graph. It's a negative square root graph. So now, I'm going to give you a graph. I'm going to ask us to graph negative. I'm going to give you a graph f of x. Now I'm going to ask you to graph negative f of x and f of negative x. Negative 2, negative 4, 2, 3, 6, 2. This is the graph f of x. Now, if I wanted graph f of negative x, okay, how would we graph that? Well, it's probably good if we found some key points on this graph. Like this point, maybe that point, this point, and the end point. We'll even give them names. A, B, C, D, and E. A, B, C, D, and E. And what are these points? That's what we like to know. Well, point A is negative 2, 0. Negative 2, 0. Point B is x is 0, and y is negative 4. Point C, x is 2, y is 0. Point D is 3, 2. X is 3, y is 2. Point E, x is 6, y is 2. Now, f of negative x. To get, so we're replacing x with negative x. That means it reflects across the x-axis. All I do is I take those same points, and all I do is I change the x value. I change the sign of the x value. We'll call them primes. A prime, B prime. Because it's no longer A, and it's no longer point B, and it's no longer point C. So let's not label them A, B, C, D, and E. Point A is negative 2, 0. So I change the sign. Point B, I change the sign of 0. Change the sign of 0, you still get 0. Only the x value changed. Point C is 2, 0. I change the sign of the x value. Okay, negative 2, 0. When you replace x with negative x, the points that you had for f of x, just change the sign of the x value. 3, negative 2 is D. B prime is negative 3, 2. Point E is 6, 2. Change the sign of just the x value. And these are the 6 points that we're going, or 5 points that we're going to graph or plot. and then we draw it. 1, 2. 2, 0 is right here. 0, negative 4 is right here. Negative 2, 0 is right here. Negative 3, 2 is right here. 1, 2. And negative 6, 2 is right here. And there's your graph. Okay, it's a reflection across the y-axis. That's all that happened. If you look at this graph and you look at the original graph, it's just a reflection across the y-axis. If you turned the page, if you have the front, you wrote it down on a sheet of paper. If you turn the page around to the back of the page and you look through it, you will see this graph. You will see this graph. If you look through the back of the page, you'll see the graph. In fact, that's a good way to do it on an exam. Draw this on a sheet of paper, the original graph, and then turn the page around. That is, just go to the back of the page and look at the graph you drew. Namely, this graph, the original graph. Look at it, and what you will see is this graph right here. Okay, that's how you do f of negative x. You replace x with negative x. If x is 7, you put negative 7. If x is negative 2, you put positive 2. The y values don't change. Okay, let's erase that graph because we need the room. And now we're going to graph negative f of x. To graph negative f of x, you take those same 5 points, A, B, C, D, and E, and since we're changing them, we should change the name of those points. And all that changes now is the sign of the y value. Instead of negative 2, 0, I change the sign of 0, which is still 0. 0, negative 4, I change the sign of the y value. Okay, when the negative is inside, you change the sign of the x value. When the negative is outside, you change the sign of the y value. It's called studying. That's what you study. To graph negative f of x, you have some points from the original function, namely these, and you change the sign of the y value. C is 2, 0. C prime is also 2, 0, because when you change the sign to 0, you get 0. 3, 2 for D. D prime, 3, negative 2. I change the sign of the y. E is 6, 2. We get 6, negative 2. And I draw this. One, 2, 3, 4, 5, 6, 7. Negative 1, negative 2. The y values 1, 2, 3, 4, 5, 6. Negative 1, negative 2, etc. And I plot. Negative 2, 0 is right there. 0, 4, right here. 2, 0, right there. 3, negative 2, right there. 6, negative 2, right here. Boom, boom, boom. There's my graph. It's a reflection across the x-axis. That is, I can go to the original graph and draw it. Just reflect across the x-axis. Instead of going up 2, I go down 2. Instead of going down 4, I go up 4. It's just a reflection across the x-axis. That is what happens when you put a minus sign in front. It's a pain. If you need to learn this, it's a pain what's going on. When you put the minus sign in front, the y value changes. But it's a reflection across not the y-axis, but the x-axis. When you have f of negative x, the x value changes sign. But it's a reflection across the y-axis. It'd be much more friendly if you changed the y value and it was a reflection across the y-axis, because then you only have to remember one. You know they're both with y. Change the sign of y, reflect across y. But unfortunately it isn't. For the top one, you change the sign of y, you reflect across x. For the bottom one, f of negative x, you change the sign of x, but you reflect across y. Okay, think about this. So learn those rules that I just stated at the end. That's the key. Okay, good luck with this.